Hello.
210, change expressed as a percent.
All right, so guys, this is our last lesson for chapter 2. Let's do it. All right, so our objective to find percent of change, and then relative error and linear and nonlinear measurements we'll get to after a while.
Right.
All right, so we're going to talk about percent increase or percent decrease. And the key concept at the bottom of the page tells you exactly what to do. Here's where you look. So you're going to do difference divided by original.
Right.
That's what I've always kind of said.
Yep.
So let's get started. All right, finding percent decrease. So a popular hybrid car cost $21,500 in 2008. As hybrids became more affordable, the price dropped to $19,780. What is the decrease expressed as a percent? So again, difference divided by original. So
find the difference between the two.
Right.
So take the bigger number.
So 21,500
minus 19,780.
Oh, here it is.
Divided by the original.
Which the original cost was the very first cost that we had was in 2008.
And then, yep.
Okay, so the numerator is 1720. The denominator is 21,500. Yeah.
1720.
1720 divided by 21,500. That's easy. We lost our little calculator tool somehow. So I got 0.08.
So this equals 0.08.
Mm-hmm.
Well, I see it said percent.
Right. So
times by 100.
Times by 100, or move that decimal two places to the
place.
right. 8%.
So this is an 8% decrease. So you need to write decrease.
Mm-hmm.
Or say
Mm-hmm.
8% decrease.
Cool.
Okay.
All right. Now, finding percent increase. In 1990, there were 1,330 registered alpacas.
You always talk about alpacas.
You know what? Because
See,
I know my friend at FT, she teaches Spanish. She's like obsessed with alpacas.
Hola, alpaca.
Yeah. All right.
Got it.
Okay, so there's about 1,300. By 2008, there was 53,000. Holy moly!
Yeah.
What is the increase expressed as a percent change? So, difference divided by original.
Okay, so you take the bigger number.
53,000 minus the sad little 1,330. Look at him though, is he not so cute?
You have to start somewhere. And where did we start? The original.
Was 1,330.
Yep.
So this is a massive increase, like more than 100%.
Right. Well, let's find out how much it is.
Okay, I'll do the math for us. 53000 minus 1330 equals 51670. 51,670. That was an increase of that many guys, divided by 1,330. I got this number, 38.8496, and some more, but we'll just leave it at that, because I know it's a percent.
Right.
So, times by 100, that is 3,884.9%.
Oh, 0.96.
Okay, 0.96.
So then you round that up
to 3,885%. That's a lot.
Increase.
I think that's what you guys are going to get on your Chapter 2 test.
Holla.
You're going to get a 4,000%. Good job. Okay, now, relative error. You can, okay, so you're going to, what you're looking at here is the estimated value versus the actual value. So sometimes we might estimate, for example, there's going to be 300 8th graders next year. Okay, that we estimate that much. Well, only 280 people showed up to be an 8th grade student. So there's a relative error there based on your estimation.
Right. Right.
And you still do the same thing. Difference divided by actual.
Yep, and it's just called percent error.
Mm-hmm.
So there you go.
Okay, so a cube's volume is estimated to be 8 cubic centimeters. When measured, each side was 2.1 centimeters in length. What is the percent error in estimated volume? Do we need to actually do the volume first?
I don't know.
Well, I think we need to do 2.1 times 2.1 times 2.1 to get, so the actual, so what I just did just now is I found the volume of that cube. So I did 2.1 to the third power, which is 9.26. And it's actually 9.261, but we'll leave it at that. Cubic centimeters. So what I'm going to do is I'm going to find the difference. So the estimated was 8 centimeters,
So we take the bigger.
but it's estimated minus actual.
Oh. Oh, okay. Got it.
Mhm.
8 minus 9.26.
Which is negative 1.26. Well, we'll do that in a minute. And then divided by the actual. So the actual was 9.26.
And we had to find this because we had to know what the volume was. Okay.
So negative 1.26.
1.26.
Oh, we're probably writing on our heads. Divided by 9.26.
Okay.
So negative 1.26 divided by 9 point, oops, that's not a point, is negative, good, negative 0.136.
136.
And then we multiply that by 100 to get our percent. So it's negative 13.6%. So our error was 13% lower. That's what the negative tells me, that I was 13% lower than what actually happened with, we're not talking about alpacas anymore, with the volume of the cube.
Now, if you look at the formula, it has the absolute value here. So your answer is a positive 13%.
Oh.
They don't care if it's in a positive or negative direction. They just want to know how far off were we.
Okie doke. Okay, so we were 13% off.
So if you wanted to tag the absolute value around this whole time,
you could.
Feel free, but just know that in the end, it needs to be a positive.
Cool. Okay, I got it. Okay, minimum maximum dimensions. The student's height is measured as 144 centimeters to the nearest centimeter. What are the student's minimum and maximum possible heights?
I think we're good without this.
Yeah.
Yeah.
Cross it out.
No más.
Keep going. What is the greatest possible percent error? Nope. Do these. Okay, hold on. Let's make sure we've got percent change, percent change. Yep, decrease, increase, and no, that's percent error. That's a good one. So good.
Oh, there you go.
That was the fastest lesson ever. Okay, guys.
Holla.
We'll see you
On the flip side.
Bye.